Thank you, Hannah. Okay, what you want to do when you're given a set of data and a problem like this, and we're going to do quite a bit of this, there'll be at least one of this kind of problem in just about every chapter that we cover, except maybe chapter 2. Chapter 2 is a little bit different. We'll definitely do some in chapter 10. What you want to do first is you want to get your calculator, and the very first thing you want to do is hit your Y equals button and make sure that that screen looks exactly like that first screen on the PowerPoint. In other words, that there are no little black boxes over plot 1, 2, or 3. And if by chance there is a black box anywhere up there like that, you simply use your arrow keys and put your cursor on top of that black box and press enter to turn it off. So no black box, it's off. Black highlighting over it, it's turned on. And you want those to be turned off to start with until you actually get ready to use it, because it'll cause you problems if you're actually just trying to graph a line if you've got that turned on. Then we're going to go second Y equals, and we're going to go to plot 1. So we're just going to press enter to choose the first one. We're going to press enter again to turn that first plot on. And the rest of the screen generally stays the same for everything. The first graph is the only one that you want. That's a scatter plot. So then you arrow down, and your X's are in list 1 because that's how we started out. We started out by putting the number of years since 1900 in list 1. And then in list 2, we've got the death rates for those years. So that's our Y values. And the mark that's easiest to read is always going to be that little box, that little tiny box. So we're going to leave it defaulted to that. And the only thing you need to do after you finish problems like this is go back and turn your plot off so that it won't interfere with anything else you're doing later on for graphing. And just leave plot 1 set up this way, and then always use list 1 and list 2 so you don't have to go resetting the plot every time. So once you've got that set up, you need to set a window that you can for sure see this data. And we could look at the data and determine how to set the window up, but the calculator is pretty smart about it. So we're going to let the calculator set up the window for us by using this screen here. We're going to press the zoom key, and then we're going to arrow down until it says zoom stat, which is number 9, choice number 9. And all you have to do after that is hit enter, and you should see your scatter plot, which is that screen in the middle of the presentation there. You should see that scatter plot, and yours should look pretty much identical to that one. Now, are the points perfectly linear? In other words, if I draw a straight line through that data, are any or all of those points going to lay on the line? No. The idea of does it have a linear model is kind of different from that, because it recognizes that in reality, things very rarely fit a model perfectly. There's going to be a little bit of variation in your data. So what I'm looking for here is basically, do the points seem to travel across the screen in a really tight band? Could I draw a set of parallel lines on either side of those points and containing those points? And the answer is yes. They do seem to have a negative slope because they're traveling downhill as you read the graph from left to right. So it does seem to have a negative linear trend. And in cases like this, as long as they fit somewhat in a little tight-knit band, as long as they're that way, then it's okay to calculate a regression equation or a linear regression equation. So what we want to do next is we're going to hit stat, but we're going to right arrow this time to calc. And when you right arrow to calc, we're going to go down to number 4, which says linear regression. We're going to choose linear regression and hit enter. And then last time I only had you put in 2 pieces of information. This time I'm going to show you how to put in all 3, because this will make it easier to do what we're going to do. So for the first one, we're going to put, where are the X values? Well, that's second and number 1 to get list 1. and then enter a comma. The comma's above the number 7 key. And then second and the number 2 to fill in list 2. And then don't hit enter yet, type another comma. And this is going to take several keystrokes, what I'm going to show you, but it'll save you lots of time. After you hit that second comma, you want to hit the vars key. You want to hit the vars key right here, next to clear. So it's that key right there. And when you hit the vars key, your screen will look like this one. Eventually. You'll start out with a menu, but what we want is not every variable this thing knows. We want what does it know about y variables, because our equation is going to be in y equals, and that's a y variable. So you right arrow over to y vars, and your screen looks like this. And then you go ahead and hit enter because you're choosing a function, because that's what we're dealing with is functions, and I keep hitting the wrong calculator. So you're going to hit enter to choose the function, and then enter again to choose y1. So your key sequence there after that second comma is vars, right arrow, enter, enter, enter is your third step.
I'm so sorry, I completely lost you after you did the number 4 thing.
Okay, let's go back from the top. I'm going to clear it.
I'm so sorry.
No, that's okay. I'm going to clear it and we'll start back from the top. Okay, the data is in the calculator.
Yes.
On list 1 and list 2. We cleared out, well, let me clear that back out again. We cleared out the y equals screen and we went to second y equals,
Yes.
chose the plot, turned the plot on, and left everything else the same all the way down. And then we hit zoom, and we chose zoom number 9, which was to fit our data to what we put on the stat window. And we hit enter. And we see the pattern, and we see that it does seem to be kind of linear. So then we hit stat once more, and we right arrow over to calc, which puts us at this screen right here. Okay? And we go down and choose number 4. And you hit enter. And then in order to get the rest of this, you press your second and your number 1 key for list 1, comma, second and your number 2 key for list 2, comma. Then we want y variables, that's on the vars or the variables button, which is right here next to clear. So you want to go vars, V-A-R-S, right next to clear, and then right arrow over to where it says y vars, which is y variables. And then you press enter or number 1 to choose function, and then enter or number 1 again to choose y1. And when you finish, your screen is going to look like that. Now remember, you've got access to this both in the PowerPoint and in the recording too. So you can always go back if you get stuck. Because after a while, if you've done it a bunch of times, you get to where you remember. But it takes practice. Yes, ma'am.
I'm sorry, I forgot. I actually had gotten through all of it, now I forgot which button you pressed to get to the second step.
To see this,
No, the one above it, the one right above it.
that,
Yeah,
second y equals,
second one.
yes.
Okay.
Okay, so when everybody gets here, you only have one more thing to do. You're going to press the enter button. And when you press the enter button, you should see what we're going to come up with for this equation. So what I chose to write last time for the equation was I kept quite a few of the decimals. You really don't have to keep that many of the decimals. You can actually round it off even further than that. You don't want to round off very much if you're using other kinds of equations than linear, but for linear it's pretty much okay. So we could round this off to negative 0.51 x plus 87.9. And that's going to give us the death rate X years after the year 1900. And we can plug in whatever value we want to for X. So it asked us in particular this time, it asked us for what would the death rate be in 2020, which would be 120 years after 1900. And we have an equation that we can use to predict that if we think the equation fits the data pretty well. Now, some of you probably got a couple other pieces of information on your calculator. Did anybody get R and R squared? Okay, if you got R and R squared, that's okay. You don't have to turn them off. You don't have to turn them on. You could ignore them because I'm not going to ask you about those. I'm going to ask you to determine whether or not the data, whether or not the line fits the data just by looking at it. So we're not going to really pay attention to R and R squared. There is some discussion of it in section 1.3, but this is not a statistics class. We're not going to do statistics, so we're just going to use the modeling capability. So that last step that I had you to do, the step here where we actually put in the Y1, actually let us copy at the same time it calculated that entire equation over to the y equals screen. So if you press your y equals right now, you should see that equation. And it's completely not rounded at all. So when you're asking me about how many decimals should I round to, you can write down only 1 or 2 decimal places if you want to on your paper. But when we actually evaluate this, there's going to be an easy way to evaluate it and get a better answer without having to do any rounding at all. So what we want is we want to find out what is the value at x equals 120. And the way we're going to do that is we're going to hit second mode to get back onto the home screen again. We're going to press the vars key again. We're going to go back over to y-vars again. We're going to choose function and y1 again. Same thing that we did at the end of the regression command. And the only thing you're going to see on your screen now is y1. And we're going to use function notation, which means we're going to put in parentheses 120 for the value of the year. So it's 120 years after 1900. And hit enter. And if we use the unrounded equation, if we use every single decimal place that it's got, it says the death rate in 2020 will be 27.2%. Or 27.213 per 100. Okay? Now that's with the unrounded equation. That's keeping everything. You'll get exactly the same answer if you use the rounded off equation like we had right here, and you type in negative 0.51 times 120 plus 87.9 but there is round off error. And the more you round off, the bigger the error is. So the exact correct one would be 27.2%, or 27.213, repeating if you want to be just really perfect. But if you use the rounded off equation, you will get a little bit of error, which means you'll get a slightly different answer. Now, if I increase the number of decimals that I used, and instead of using 5.1, if I had used 5.06, and instead of 87.9, I had used 0.882, I get a lot closer, but still there's a little round off error. So just remember it. The number one thing to pay attention to is if you're told how to round off, go ahead and round off. If you're not, then there's no reason not to actually use all the decimals, all the digits, because they're going to be stored in your calculator anyway. And you don't have to type them back in to be able to do that. If I give it to you on a test, I will tell you how many decimal places to round to, so that we'll all be agreeing on what the answer should be. I'll probably say round to the nearest hundredth or round to 3 decimal places, and I probably won't ever say round to the nearest whole number. Yes, ma'am.
I went back to the original question, so if I put the answer down, I just times it by 1,000. So what are the percentage? Is that okay?
Let's see, what did the original question say? Yes, this is deaths per 100,000. So the rate actually is 27.213%. If you multiply that by 1,000, that means in that year that will be 27,213, or thereabouts, depending on how much round off. Is that what you're asking about?
Yeah, just see if that's okay to answer it.
Yeah, yeah. And since it's 100,000, actually, it would be in the millions. I misspoke when I said it would be 100,000s, it would be in the millions. So let's go back to the PowerPoint and pick up from there.
Can you go back under slide where you're showing the work?
This one,
Where you're showing the work?
right here. Now the one that I actually have in, I think there's an error in the last, yeah, there's an error in the last couple of screens on the calculator. I'll have to correct those. Let me go back to the PowerPoint for just a second. I left these up here because if you notice, the least squares regression line that we got did not have the same y-intercept. What changes if you don't scale the data and use 20 instead of 1920 and 30 instead of 1930? If you put in 1920, 1930, 1940, and so forth, what it changes is your y-intercept. Okay? And your y-intercept is going to be exaggerated by quite a lot, but you'll still get exactly the same death rate because you're putting in the same x values. The only difference is if I'm going to use this model I'm actually going to plug in the year. So in this model, I would plug in 2020 because I didn't scale the data. And if I don't scale the data and I were to plug in 2020, I would get negative 0.5 056, because that's how much I rounded in the PowerPoint, and put in the year 2020, not years after the year 1900, but the actual value of the year, plus 1,048.4764, I still get pretty close to the same death rate. Okay, again, there's still a little bit of round off error because I did round off both those numbers from what was actually on the calculator, as you can see right here, and compare that to the equation I wrote out. But it still comes out okay, even though it changes your y-intercept. What you want to be careful of is when you write your model, you write it in terms of what each one of these variables measures. On this one, instead of calling that y, I said this is the death rate. And the death rate is equal to negative 5.056 times the year for that death rate, plus 1,048.4764. Whereas on what I did on the overhead, we scaled the data and used these values instead of these. And because we scaled the data, then X measured the years after 1900 instead. My equation still predicts fairly accurately, depending on how much you round off. But this is the death rate in 2020, and that's because 2020 is 120 years after 1900. So spell out what you let X mean. Scaling the data is usually a better idea, though, because, you know, big numbers like 1920, 1930, and so forth just make your work harder. You have to type in more numbers. So usually it's easier to scale your data. So anybody have any questions before we go on this one? Okay, the other way that I showed you in the PowerPoint, go back to that for a minute. I went in and actually manually set the window using the equation that I had for that. And see, I'm still getting 27.2. And the other way that I could have gotten the answer is you can hit second calc, choose value, and tell it, now remember I'm using here, it's 120 years since 1900, so I'm going to ask it on the graph screen, where's X equal to 120? And for some reason it didn't like that. Let's see. Oh, because it didn't let it go all the way up to 120, so I'm going to let it go up to 125. And it'll tell you the same thing, and it'll show you where that is on the graph screen. Okay? So there's more than one way to actually get that prediction. The one that I showed you is probably the easiest, to have it stored in Y1 and then do Y1 of whatever the number of years is. So let's look at another example and see how we can do with this. Yes.
Okay. In the formula that we wrote,
Mm-hmm.
the B, the last.
Right. That's your y-intercept, and
Why was there a difference on the? Because we got 87 and 88. How was it that really big? The argument?
because, okay, what we did was we scaled the data, and instead of putting in 1920, we put in 20.
Gotcha.
And 1930, we used 30. If you had actually used for your X values 1920, 1930, 1940, 1950, and so forth, that bigger y-intercept comes from using those.
But it didn't affect the other.
It doesn't affect the rate of change, no. It doesn't affect the slope, but it will affect the y-intercept.
Okay.
So the equation will still work just fine. You've got to remember, how did you set up X? What did X measure? Did it measure the actual year? Or did it measure the number of years after some set starting point? And once you enter in the correct X value, then the equation will take care of whichever way you entered it in. And you'll still get the same answer. Okay? This is just the rest of, this is the way that I did it when I did it with x equals 120. So I've got both of them in there for you. Yes?
I don't know how you got to the point of getting, like, from the previous screen where you had the y equals, how you got the answer for
This one?
yes.
On this one, I plugged in 120 years. I think I forgot to alter the,
Yeah, the last thing I have is the y equals all the screen right before that. So I didn't know how, yeah, that last one.
okay, does yours match this or does it match what we just did in class?
It matches what we just did in class, but.
Okay, the reason it matches what we did in class is because we scaled the data in class.
Yeah.
That's the same question that he's asking. If you don't scale the data, what you wind up getting is just a bigger y-intercept.
Yeah,
Because
I'm
X
just
no
trying to
longer-
figure out how you got the 2020 answer that we just got, because I can't figure, I'm still trying to figure out.
Okay, let me see where you are on your calculator, because it might be easier to address
Yeah, sorry.
one-on-one. No, that's okay.
Just, what do I need to know?
Okay, go back to your home screen, second motion. Second in this button. Now, bars. Hold your Y bars. Choose function. Choose Y1. And then parentheses, put 101. And there's your F. And even if you didn't match what we did in class, if you used 19, 20, 19, 30, 19, 40, and so forth, the only thing that changes is the y-intercept of your equation changes because x no longer represents how many years after 1900. Now it represents the actual year. And in that case, the y-intercept's going to have to go up. Okay? Mhm. It depends on whether you put this in for X or did you put in 20, 30, 40, 50. Okay, then yours is gonna work fine. Okay, there's the rest of it. So see, you got the larger intercept because you typed in the raw years. You didn't scale the data. And it's not wrong to not have scaled it. You're still gonna get the same answer in the end, the 27.225. We're gonna round that answer off to 27.2 regardless. So you're gonna be okay whether you scale the data or you don't. Okay, I'm going to skip over this because it's a matter of using both equations. So go to example 3. You don't even have example 2 on your paper. So go to example 3. And it says, in what year is the death rate predicted to drop below 26 per 100,000 population? Now we can use either equation, and I'm going to write them both up here. So we can compare. So if x equals the year, we're going to use the equation shown on this screen here in the middle. And I'll switch over here to the overhead in a second so you can see what I'm telling you. Okay. We're going to get the same answer regardless of which way we go on this. So for those of you, like the two of you in the back, I think both did this, or maybe all three of you back in that area, if you actually use the year, 1920, 1930, 1940, 1950, and so forth, this is what your model will look like. If you did it like we did it in class this morning, and you used the number of years since 1900, which means that you used, for 1920 you used 20, for 1930 you used 30, for 1940 you used 40, and so forth, then you got this model. Notice that the slope of both models is exactly the same. The rate of change is the same. The only reason that this is different is that represents 87.88 years after 1900, and this represents the year 1048. Almost 900 years before 1900. Okay? The actual year 1048. This is where you're using the year and this is where you're using the scale years. But notice what's going to happen. First of all, on my calculator with the one that we did today, what I want to enter in at Y2, it says, in what year is the death rate going to drop below 26 per 100,000? So in that case, my Y value is going to be 26. Okay? And I'm going to just hit graph again. And for some reason I'm not seeing y equals 26, and that will be because X-Men started above 26, so I'm going to have to put in 20 and hit graph. And this point where those two intersect is going to give me the answer. So second, calculate, choose number 5. And using this model, the one that we did this morning, it says in the year 122.4, or X equals 122.4, which means 122.4 years after 1900. What year is that? It's 2022, actually about halfway through, not quite halfway through 2022. So in 2022, the death rate will be below 26, or 26 per 100,000. Okay?
How did you get that to show on the calculator? You just,
I just set my Y2 equal to the number of years since, oh no, I'm sorry, I set Y2 to be the 26 death rate. Okay? The 26 death rate.
And then you press, oh, so, I'm sorry, go ahead.
I set my Y equals as 26.
Okay?
And then I don't know what I did next. I don't know if I'm supposed to hit graph or second.
You're gonna have to go first to your window, because your window, since we let the calculator set it, your window's probably set to something higher than 26 for the minimum value. So you're gonna have to lower your Y minimum value to something less than 26. And I just chose 20 because it was convenient.
And then you press graph?
And then I hit second, and you can hit graphs so that you can make sure they actually are crossing. But then once you see that they're crossed out there, then you're finding out what the intersection point is.
So how do you get that?
Okay, from here,
Yes.
I made sure first that my window actually included the Y value 26, and now it does because it goes from 20 to 88. And then I hit second, trace, went down and chose the intersection point. And then hit enter 3 times is all you have to do after that, and it finds out where the intersection point is, which tells you 122.399 or 122.4 years after the year 1900, the death rate will be 26. Okay? 26 per 100 million. Now, the only difference in this model and the other one, and I'm going to go through this from the top to make sure everybody understands what the difference is. I'm going to go back to Stat and Edit. The only difference is the one that's got the big Y-intercept, the 1048 Y-intercept that you see in the PowerPoint slide. Instead of using 20, what's being used there is 1920 and 1930 and 1940 and 1950. So we're using the actual years. And if I go back and start all over again from the top using this data instead of the scale data, Stat, Calc, Linear Regression, List 1, comma, List 2, comma, bars, over to Y bars, choose function, choose Y1, and hit enter, it gives me the exact same slope. This slope and this slope are the same. What changes is because you change the actual value of the x's basically by 1900 years. Then it gives you the y-intercept in terms of what year it actually is. But if I use that equation now and I try to say find when the death rate goes below 26, first I'm going to go zoom, stat to make sure it fits the window for me. Notice the graph stayed the same. I'm going to check my window, and again, my window doesn't go below 26, so I need it to go below 26 for me to see where y is equal to 26. So I'm going to change that to 20. So I still have pretty much the same graph. The only thing is it lowered my bottom of my screen down a little bit. So if I go over here to y equals and I actually graph this, what I see is that y equals 26 intersects my model somewhere out here toward the edge of the screen. The only issue I've got is if I look really carefully, I see it doesn't quite cross. They come together, but they don't quite cross. And if I try to do my intersection point right now, it says I can't. I can't find it. And that's because the intersection point isn't actually on that window yet. And the reason it's not on that window yet is because X isn't going to 2020. It's only going up to 2019. And we already know that it has to go to the year 2022 because we've already done the problem with the other data. So if it only goes up to 2019, let's just let it go up to 2030. And now you can see the intersection points. You can't just see that there's going to be one. You can see that there actually is one. So you can find the intersection point by using second calc and choosing number 5. And notice that it says in the year 2020, 2022, which is the exact same answer we got here.
It's showing the point, or is it showing the line?
That's what mine's doing. I'm confused.
Are you not seeing this line?
It's not showing a line going in between the points.
Get your y equals straight, I'll say.
It's straight up here.
Okay,
When we
your
first
y
started.
minimum value is 26.095, more than 26, right? So you can't see 26. Go back to your window. And go something lower than 26. Now try. There it is.
It's not showing.
The other one still should come in this. I think it was because your cursor was on. No? Why is not showing?
We did that from the beginning of when we started practicing this problem, and then something did.
Okay, but you got the same line set that I had before. So,
Oh, that's fine.
yeah, so we want the window. Let's go back and do some of it again. Okay, you got the 1927. Let's start at the top. Stat, cal, number 4. This one, this 2. Bars, y bars, function, y1. Yep, we get this one. Okay, now we got it. So now there's the correct equation, because if you put the years in, that has to be the line set. You put the actual years in. This is when X is equal to 19, 20, 19, 30, 19, 40. That's what you have.
That's the,
Yes.
this multiplier.
Actually, it's with, I think it's with 1900 subtracted from. So then if you actually do it now, there goes your graph. But you still can't see your y equals 26, because now the window still doesn't go below 26. So lower it down so you can see both. Okay? Anybody else have any problem?
I think I figured mine
Okay, this first one's confusing because there's two different ways to put the data in, but you get the same answers as long as you use the equation you get. So what we're doing basically is we're letting the calculator solve this problem for us so that you can kind of get an idea of why we're doing what we're doing. If we're using this equation, which is the one where the years are the actual years, then what we're doing is we're setting that equation equal to 26 and solving for x using algebra, okay? Which means we're going to take 26 minus this value, is equal to negative 0.505575, however many other decimals there are, x, dividing both sides by that slope. Get rid of that, and we're finding out that x equals whatever. Let's see if we can do the arithmetic here. X is equal to 26 minus 1048.4763 divided by negative 0.505575. And we get, in this case, because I rounded off again, remember, the more you round off, the more your answer is going to change. Because I rounded off, it says it's going to be in 2061. Okay? That's just because of round off. And if I use the other equation, I'm going to get the same sort of problem because I'm going to wind up with round off error. If I use the equation we get when we let x be the years since 1920, which is x is 20, 30, 40, 50, then we have same slope, only the y-intercept changes because our x values changed. So if I set that equal to 26, then I'm going to have 26 minus this y-intercept is equal to that same slope. So I'm going to divide both sides by that same slope. It's 505575. So that I'll have just x on this side. Oh, wait. No, I see what I did on the other. Let me back up. It's not just round off error. It's entering it on the calculator error. I left out the 20. That's why it was off so much. Okay, so we come up with 2022. Okay? Which is what we pretty close to what we came up with before. It's off by a little bit out here in the decimals. So that's a matter of days, not years. And then if we do 26 minus the 87.88. And divide that answer by that slope. It doesn't look like the same answer because this is the year 2022 and this says 122.39 or 122.4. But if I add 1900 to that, because that's the number of years past 1900, then I get 2022. Okay? The key thing to do when you're doing this kind of problem for me in chapter 1, section 3, is tell me what you let x equal. How did you put x into your calculator? What is x measuring? Is it measuring the actual year, or is it measuring how many years since 1900? Okay? That's the key. You have to be clear on what x and y actually represent. That's going to be very important when you get to calculus. And so I've given you in the Nearpod lesson, there's your scatter plot, and this is actually scaled with the years, and it works just fine. So here's one for us to practice with. I'm not going to do this one with you because this is for you to practice, but I think we might be better off doing another example first, so let that one sit there for a minute. I'm going to pull up one out of the book. So we're actually going to do one out of the homework. And if you watch the videos that I gave you to watch, these questions are all answered in the videos. So I'm going to skip the one where we're actually going to do a problem. Okay, so here's a set of data we're given outright what to put in the calculator. So what we're going to do is we're going to enter the data. We're going to practice a little bit and then go back to that other problem. I'm going to clear off all my screens so I can start fresh. And remember, I start out with the plot turned off until I know I'm ready to turn it on. I turn it off. So that screen should look like that. My home screen should be blank. I go to my stat, choose edit, and then delete, 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 delete till I get rid of all those. And then enter in your x values, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then enter in your y values. Don't be upset when it lops off your 0.0 after your 1. It'll do that. So put your data in. And because I notice here, this particular homework asks you to calculate the correlation coefficient, everybody that didn't see r and r squared, follow along with me. The rest of you that saw r and r squared, you don't have to do that. But if you do it along with me, it won't change anything. So from here, just this one time, we're going to go second mode to get off that screen. Second mode gets you out and takes you back to the home screen, wherever you are. Then hit second and the 0 button, and you should see catalog. Scroll down. Just hold your down arrow button until you get to the D's. You'll want to slow down when you get to the D's. And I want you to find diagnostic on. Turn your diagnostic on. So put your second 0. And then scroll down to diagnostic on. They're in alphabetical order. Once you get to diagnostic on, hit enter 2 times. All it says is it's done. That's all you want it to do. It's going to calculate r and r squared for you. So now that we've done that, I'm going to clear that back off again. Go back to stat, just like we did before. Go over to calc, because we've got the data in. Go down to number 4, linear regression. Type in your list 1 and your list 2. Then to get your Y1, you press bars for variables, right arrow to Y bars for Y variables. Choose Y1 functions, so choose function and then Y1 just by pressing enter twice. And now that you've got your command, then it says len reg ax plus b, a is the slope, b is the y-intercept. List 1 is the x values, list 2 is your y values, and your Y1 is where it's going to store your equation. So you just hit enter. And everybody should see exactly what I'm seeing now. Okay? So the first thing it says is draw a scatter plot. Okay? Second, y equals, choose the first one and turn it on. Everything else should be set up. So just choose plot 1 and turn it on. That's all you need to do. And then hit zoom and the number 9 key. And what you're doing when you hit the number 9 key is you're choosing zoom stat. So there's the scatter plot, and you're also seeing the line drawn through it, and that's a really good fitting linear equation. Those points are really close to that line. So it says draw the scatter plot. Well, we need to look and see which one of these our scatter plot looks like. So let's see, it doesn't look like that because it doesn't level off there in the middle. It looks sort of like that one. So that one might be it. Doesn't really look like this at all. And that one's going the wrong direction. It's going downhill and ours is going uphill. So the best answer is the second one. So you check your answer and it says, okay, good job, you picked the right one. And the next says calculate the correlation coefficient. The correlation coefficient is the value of R, the very last number you see on that first screen, 0.98754. Always second mode will take you back to this screen. Okay? Now it says, don't round until the final answer and then round to the nearest thousandth. Thousandths is 3 decimal places. So it's 0.98754. 5 says I need to change that last 7 to an 8. So it's .988.
How'd you do that?
It should be on your screen. Yours is not. Go right there. Let's go back to what you got. Oh, this should be 1, not 1. I think that's the other thing. Okay. This is this. Okay, you're,
No, actually, I can tell that.
yeah. Are you doing the same one that I'm doing? Okay. We'll go with what I've got. So 0.3, 1.0, 1.3, 2.3, 3.1, 3.3, 3.3, 4.6, 4.8, 5.3. That's the one I'm doing. Correlation coefficient is R, and it says round to the thousand. Just third decimal place stuff, 8.988. Okay? And the only thing you're gonna do different to do yours is just change the Y values. Are you using the data on your problem on your screen, or are you using the data that I'm using? If you pulled up the homework problem, your numbers are gonna be different from mine.
Okay, yeah.
Okay.
Yeah, I was.
Yeah, if you're using what's on your screen, that's good, because you're following along to the homework. But your answers are not gonna be the same as mine, because my data values are different from yours. Because I'm in, just like you are as a student.
How do you get it to graphic?
You hit zoom and number 9.